Hello everyone. In this video we will learn about IP address, their classes and subnetting, how to perform subnetting. So IP address, ना कि वहां पर हो गया क्या? कॉलेज वाले याद था लेकिन बना दिया। जब रिकॉर्डिंग रिकॉर्डिंग करने जहां बैठा गीला हो गया वहां पर बड़े पसीने आ रहे तो यार Hello everyone. In this video we will learn IP addresses, their classes and subnetting. How to perform subnetting. IP address, this address is actually used at network layer. Whenever a packet has to be sent from one network to another network, IP address is used. So IP address is used for internetworking, and this address is having 32 bits. So these 32 bits uh, are shown as 4 bytes, and for better interpretation these bytes are separated by colon. So this is only for human interpretation. In actual they are stored in binary without any colon. So binary notation for IP address is like this one. It can also be represented in a decimal format. Every byte will be converted into decimal, and these 4 decimal are separated by dot. So in binary format we use colon, decimal, dot, and there is one more notation, that is hexadecimal notation, and this notation is continuous. So the most used notation is dotted decimal notation. This is only used for better understanding. Otherwise, in actual, IP address is stored in form of binary. Now there are 5 classes of IP addresses, and these are the tricks by which you can identify in which class your IP address belongs. So what you have to do, these 4 blocks are representing 4 bytes. So if the first byte is having 0 in the beginning, or you can say most significant bit of first byte is 0, in that case that IP address belongs to class A. If it is 10, it belongs to class B. 110 class C, D and E then. So this is the one way. So if a IP address is given to you, and if someone asks, can you tell me the class for this IP address? So what you have to do, you have to convert only first decimal into the binary. Then you have to see whether the first bit is 0, or the first 2 bit 10, or first 3 bit 110. So if any of them are matched, let's say this one is matched, so you can say that IP address belongs to class B. So this trick you can use if the binary notation for IP address is available, or if you know the conversion process from decimal to binary. But in case if you want to find out quickly, there is a shortcut as well. So if the first decimal is in the range of 0 to 127, then it will be the class A. For this range, class B. 191 to 223, class C, class D and class E. So let's have a example. Let's say we are having a IP address. So this is our IP address in binary notation, and we want to find out what's the class for this IP address. So we will look for the first byte, and in this byte the first bit is 0. So it is matched with the class A. So this IP address belongs to class A. Now let's have a look on another example. We are having 193.14.56.22. So here 193. One way is that you can convert this 193 into binary, and then you can check starting bits, or you can use these ranges as well. So our 193 lies somewhere here between 191 and 223. So this address belongs to class C. Now every IP address actually having two information. First one is network ID, second one is host ID. What is network ID? We will see that thing in later slide. So our 32 bits are divided into network ID and host ID. So and we are using to represent network ID, and the remaining bits are host ID. So for every class there is a different network ID. Like for class A there are 8 network ID. For class B there are 16 network ID, 16 bits, sorry, and for class C there are 24 bits used as a network ID. Class D is used for multicast addresses, and class E is reserved for future usage. Now this question is asked frequently. One address will be given to you, and in the question it will be asked, can you tell first address of that network and the last address of that network to which this IP address belongs. So if you want to find out first address, so what you have to do, you have to take network ID as it is, and you have to put remaining bits as 000. This will be the first address of the network, and last address you have to take network ID and put remaining bits 1111. So let's have a example, then it will be more clear to you. Let's say we are having a address 75 45 34 78, and we need to find out first address of the network to which this address belongs. So what we will do, first we will convert this IP address into the binary, and by looking at the starting bits 0 1, we can say this belongs to class A. So in class A, you need to remember this one. For class A, network ID is 8 bits from this side. Most significant 8 bits. So these 8 bits are network ID. Okay. So these are network ID, remaining are the host ID. And we want to find out first address. So in the previous slide we have seen, if we want to find out first address, we have to take network ID as it is and remaining bits will be filled with 0. That will be the first address, and if we fill remaining bits with 1, it will be the last address. So we want to find out first address. We will take network ID as it is and the remaining part we will fill it 0 0 0 0 0. So if we convert this number into decimal, we will get 75 0 0 0 0. So this is the starting address. And if we want to find out last address of this network, we will take network ID as it is and we will make remaining bits 1 1 1 1. And this is the decimal format of this one. So for a network to which this address belong, first address is this one and the last address is this one. So what you need to remember, first you need to remember network ID, how many bits are reserved for network ID. In class A 8 bits, class B 16 bits, class C 24 bits. Next, if you want to find out first address, take network bits as it is and fill remaining with 0. This will be the starting address, and for last address, fill remaining bits with 1. It will be the last address. Now here I will explain what is network ID. So we are having a network here, as you can see. IP address for these nodes are 73.0.0.1, then 2, then 3, and this is the router. Now every router maintain a routing table, like for a particular destination what will be the outgoing port. So the question is that how many entries this router is going to store for this network. Is it going to store one entry for each node? So if we are storing one entry for each node, routing table will be very huge. So in order to solve this problem, every network is assigned a network address, and by default the first address is assigned to network. So what this router will do, this router only will store single entry, and that entry will be stored for network address. Like if any packet arrived for this destination, send it to port 4. So we have stored a single entry for that many number of nodes. So this is also known as address aggregation. So it will actually reduce the routing table. So here comes the network address. Every network is having a network address. Now the question is that this router is having this information, like if a packet arrived for this destination, forward that packet to this port number. And if you can see, node are having address 123 253 254. So when a packet arrived here with this destination, how this router is going to find out this destination, this target machine actually exists in this network? So here comes the role of network mask. So network mask, this is a 32 bits number in which n leftmost bits are ones and remaining bits are 0. So here the value we are using n, and this value change according to class. So in class A we are having 8 bits for network ID, class B 16, class C 24. So network mask, in network mask we are having n leftmost bits ones and remaining 0. So let's have an example first, then it will be more clear to you. So if we are having an IP address of class A, So we know class A is having 8 bits reserved for network address, sorry, network ID. So how to find out the network mask for class A? We will put 8 times 1 and remaining 0. So this is the network mask. For class B, network ID is 16 bits. So there will be 16 ones and 16 0. For class C, 24 ones, 8 0. So network mask is used by router to find out network address of destination address. So we will see how this router is going to find out. So what this router will do, this router is having this idea that for this network, this is the network mask. So whenever a packet arrive here, this router will take the destination address and perform a AND operation on that address with network mask. And after performing AND operation, the result, this is the result, and this, if we convert this result, it will give us 73.0.0.0. So after performing this calculation, this router will compare this result with the stored entry. So this one will match with this one, and this router will find out this packet has to be forwarded on port number 4. So network mask used by router to find out network address for a destination. So here this network is having some nodes. Network address, we are claiming this network address is this one, and there is broadcast address. So in broadcast address, the last address is actually used for broadcast address in that network. Or another way, network ID we will take as it is, and the remaining bits we will fill it once with ones. So 20, 255, 255, 255. So broadcast address. So if a packet is having broadcast address as a destination, that packet will be delivered to every node in the network. So now we will see what is subnetting. When we are having a large network are very difficult to manage. So dividing those large network into smaller network is known as subnetting. Okay, so here I am giving you a pictorial representation. Here we are having a single network, but here we are having 4 networks. Okay, and this is the, let's say this is the external router. This external router will be having a single entry for this network. In this case as well, this router is having a single entry. After forwarding that packet here, this router will decide to which network that packet has to be forwarded. So for external entity, our network is similar, same as compared to previous one, but that network is actually divided into smaller network. And conceptually how we are doing that subnetting. So as we know, every IP address is having a network, some bits reserved for network ID and remaining bits are for host ID. So in subnetting, what we actually do, we will take some bits from host ID and we will consider those bits as a network ID. So we actually expand network ID, and how much we need to expand, it depends on how many smaller network we want to make. So subnetting, it's better for security and management. We can manage smaller network better than large network. As we know, class A and class B almost depleted. So class C having smaller blocks. So in case if we want IP address for large number of nodes, so we can take multiple class C blocks and we can use subnetting. Plus, if a organization is having a large block, that organization using subnetting can share one network with other organization. So here we will be having our example how to perform subnetting. So let's say this is the question. A IP address is given and the question is that create 8 subnetwork of a network to which above IP address belongs. So first of all, what you need to do, you need to find out to which class this IP address belongs. So this is 193. So one way you can convert this first byte into binary and you can check starting bits, or another way you can use the short trick. So this one uh, belongs to class B, and in class B network ID, the number of bits reserved for network ID are 16 bits. So this is the binary notation for this IP address. So from this IP address 16 bits are reserved for network ID. So these bits will not be changed. For assigning host addresses, only these bits will be changed. So network ID 16 bits, and what we want to do, if we look at the question, we want to create 8 subnetwork. So this is the important metric, how many subnetwork you want to create. It will give you how many bits you have to take from host ID. So we want to create 8 subnetwork. So this representation is the this one, 16 bits for network ID, 16 bits for host ID. So what we will do for subnetting, we will take some bits from host ID and we will include those bits in network ID. Now the question is that how many bits? So there is a formula. Formula is log to number of subnet. So in this question is given, you need to create 8 subnetwork. So you will put that number here and you will get 3. So it means you need to take 3 bits from the host ID. So here we are having the initial 16 bits and 3 more bits are taken from the host ID. So now our 8 subnetwork will be having 19 network ID or 19 bits reserved for network ID. So this is a class B address, network ID, number of bits for network ID is 16, subnetwork ID will be 19 bits. 3 bits will be taken from the host. So if you want to find out the network mask for this one, so we know we need to, if we need to make 19 ones and remaining 0. So this will be the subnet mask for our subnetwork. And if we look at this IP address which belongs to class B, network mask for this address is 16 ones, 16 0. So this is the subnetting. In next lecture I will show how to assign addresses to different subnetwork. Thank you very much for watching.